All right, let's dive into another Mtel question. This one says, use the fractions below to answer the question that follows. You got these four fractions, and then it says, given that the four fractions shown are reduced to lowest terms, which one will have a terminating decimal equivalent? So a terminating decimal is just a decimal that stops, and a repeating decimal is not a terminating decimal. So I think probably the most recognizable one, I think most people probably know that 1/3 is 0.333 repeating, right? So that is not a terminating decimal. Any denominator that has a 3 in it has the possibility of being a repeating decimal. So if any of these numbers are divisible by 3, we can immediately eliminate them. I can immediately tell that 270 is divisible by 3 because 27 is divisible by 3. So I'm going to just eliminate A right off the bat. 450 is the same thing because 45 is divisible by 9, which is also divisible by 3. So 450 is divisible by 3. So I'm going to eliminate A and B immediately. These other two are a little trickier. I'm not sure if they're divisible by 3. There is a trick to see if something's divisible by 3. You can add up all the digits, and if the sum of the digits is divisible by 3, then the number is divisible by 3. So 1 plus 2 plus 5 is 8, which is not divisible by 3. So the C one is not divisible by 3. 3 plus 2 plus 5 is 10, which is not divisible by 3. So these two are not divisible by 3. So I can't immediately eliminate either one. So what I'm going to do is a factor tree to see what the factor of these numbers are, to see if I can figure out if there's some number that might cause them to be a repeating decimal. So if we take 1250, I can immediately see that 10 goes into that because it has a 0 on the end. So hopefully you're familiar with the factor tree style of this factorization. If not, this is how this works. I'm finding numbers that multiply into 1250. So I'm saying that 10 goes into 1250, and I know that 125 times 10 goes into 1250. And I'm just going to keep factoring these numbers until I get to numbers that can't be factored, and those are the prime numbers, and that'll give us the prime factorization, what we call the prime factorization. So 10 is just 5 and 2, and both of those are prime numbers. So I'm done with this side of the tree. 125 I know is 5 times 25, and 25 is 5 times 5. So the factors of 1,250 are just these numbers at the end of the branches. So we got at the very bottom we have a 5, a 2, a 5, a 5, and a 5. So our prime factorization would be 2 times 5 times 5 times 5 times 5, or just 2 times 5 to the 4th power. So our only factors of 1250 are 2 and 5, and 1/2 equals 0.5, which is not a repeating decimal, and 1/5 just equals 0.2, which is not a repeating decimal. So C looks very good to me. It looks like we have no numbers that would cause a repeating decimal, but let's factor 3250 just for the sake of it to see what might be leading that to be a repeating decimal. So we got 3250. Again, I can tell that this is divisible by 10, so I'll just do 10 and 325. 10 is 5 and 2. And 325 is definitely 5 times something. I'm not sure what. 5 times 65? Yeah, 65. And 65 is 13 times 5. So 13 is a weird number. I'm not exactly sure what the repeating decimal is, but 1/13 must give us a repeating decimal. So that 13 is responsible for making it so that D could have a repeating decimal, and our answer is C because it has clean factors that don't result in repeating decimals.